Good morning, students. In my last video, which I have uploaded yesterday, we have learned so many definitions. We have called the basic terms of geometry and their definitions. We have seen about the point, line segment, angle. Again, we can say ray, collinear points, non-collinear points. We have seen about the angles. We have seen about adjacent angle, complementary, supplementary, lot of things that which are called as the basic terms of geometry we have learned. All these definitely help you in solving the problems of lines and angles. Before I start the problems of lines and angles, there are few more definitions. Definitely that also will help you very much in solving the problems. And the remaining definitions, and I am going to teach you one axiom also. Axiom, a new word for you. I am going to explain what is an axiom. When I start that part, I will tell you. That also we are going to study. And let us see the remaining definitions. Okay. And we start with linear pair of angles. Very, very important. Linear pair of angles. Linear pair of angles. I can say one of the very, very important definition. Linear pair of angles. What it means? Listen first. Now you know what are adjacent angles. There must be two angles like this. There must be two angles. One angle is this, second angle is this, and this is called as a common arm. This is called as a common arm. This is first angle. This is the second angle. This is a common vertex. This is a common vertex. First angle, second angle, and these are the two arms of the first angle. These are the two arms of the second angle, and this is called as a common arm. This is called as a common arm. What are these two? These two are called as non-common arms. See properly. This is the common arm, and these two are called as non-common arms. What are you got? Linear pair of angles. If the non-common arms, if the non-common arms of, if these not required, if non-common arms of adjacent angles form a straight line, form a straight line, then those two angles form a linear pair. Then those two angles form a linear pair of angles. What does it mean? If the non-common arms required, if the non-common arms of adjacent angles, that means to form a linear pair, the angles must be adjacent angles. To form a linear pair of angles must be adjacent angles, and the non-common arms must form a straight line. I will show you how they are forming a linear pair. See here, let me draw the first angle. Say this is the first angle. Okay? And somewhere here I can draw the second. If I draw here, no doubt this is called the common arm. But what the condition says? The non-common arms must form a straight line. That means my second angle must be like this. See, my second angle must be like this. See, so I will call this is A, O, B, and I will call this as C. My dear children, here there are two conditions I am satisfying. First of all, the two angles must be adjacent angles. See, I will mark them. This is the first angle and this is the second angle. Are they adjacent? Yes, because these two are having a common vertex also, and these two are having a common arm also. See, these are the two arms of the first angle. These are the two arms of the second angle. this is called as a common arm. So no doubt angles are adjacent. Angles are adjacent because there is a common arm and a common vertex. So they are adjacent angles. First condition satisfied. And they say the non-common arms. These are called as the non-common arms. They must form a straight line. They are forming a straight line. If the non-common arms are forming a straight line and the two angles are adjacent angles, then these two angles are called as linear pair of angles. So I can say angle AOB and angle BOC and angle BOC are what? Linear pair of angles. They are called a linear pair of angles. My dear children, I want to ask you one thing. Can I call them as a supplementary angle? See, first of all, I can call them as an adjacent angle. I can call them as a linear pair of angles. Can I call them as a supplementary angles? Yes, because the sum of two angles is equals to 180 degree. So definitely you can call them as supplementary also. But supplementary need not to be adjacent. Supplementary angle need not to be adjacent. You can draw like this one. See, this is the first angle and this is the second angle. You can draw like this also. This is the second angle. Say somewhere this is 130 degree, somewhere this is 50 degree, the sum is 180. So this is also supplementary angle. But these are not forming a linear pair because they do not have a common arm. So they are not adjacent. Their non-common arms are not straight. So this is not a linear pair of angles. This is not an example for adjacent, but this is an example for adjacent also. Because common arm is there. This is an example for linear pair of angles also. This is an example for supplementary angle also. So this is about your linear pair of angles. I will go for the next definition. This is vertically opposite angles. Vertically opposite angles. Vertically opposite angles. What are these? Name itself says vertically opposite. Vertically opposite. This is the first straight line. This is the second straight line. When two straight lines intersect, the angles opposite to each other. The angles opposite to each other. The angles opposite to each other are called vertically opposite angles. These are also called as vertically opposite angles, and these are also called as vertically opposite angles. We can say two pairs of vertically opposite angles are formed. I can say when two straight lines intersect each other, the angles form opposite to each other. Angles form opposite to each other are called vertically opposite angles. They are called as vertically opposite. Let me draw a figure for that. Okay, so these are the two straight lines. I will call P, O, Q, and I can call this as A, O, B. So these are the two straight lines intersect. When two straight lines intersect each other, the angles form opposite to each other. I can call these two angles. Are called as vertically opposite angles. I can write here Again, this is the first, this is second. Angle POA and POA and angle BOQ. BOQ are vertically opposite angles. Okay. I can add one more thing. Vertically opposite angles. Okay, say pair of pair means two. Pair of vertical opposite angles are equal to each other. Equal to each other. That means if I say this is 100 degree, this is also 100 degree, and if I say this is 80 degree, this is also 80 degree. This is all about your vertically opposite angles. Linear pair axiom. Linear pair axiom. Axiom. But children, this axiom word is new for you. The meaning of axiom means self-evident truths. Self-evident truths which do not have any proof. We have to accept it. For example, I can give an example for axiom. When equals are added to equals, the whole are equal. Equals are added to equals. That means, see, here you are having a 5 kg of sugar. Here also you are having 5 kg of sugar. For this also I will add 2 more kg. For this also I will add 2 more kg. Then the whole will be equals to this is also 7 kg. This is also 7 kg. So we say if equals are added to equals, the whole are equal. This is what axiom. Axiom means self-evident truths which is not having any proof. So we have linear pair axiom. There are 2 axioms, very important. Sometimes they may ask you the examination for 2 marks. Give the axioms for linear pair or give the linear pair axioms. What is the linear pair axiom? I will write down. The first axiom: if a ray stands on a line, if a ray stands on a line, the adjacent angles, I can say the sum of adjacent angles so formed is 180 degree. I will explain. Okay, what is the meaning of this? This is the first axiom, and the second axiom also I will write. Both are very important. The second axiom: if sum of two adjacent angles is 180 degrees. Sum of the two adjacent angles, very important, adjacent angles is 180 degree. Then the non-common arms of adjacent angle, non-common arms of adjacent angles forms a straight line. With this we will end. First let me explain what the meaning of this. If a ray stands on a line, this is a line I have drawn. Let me call this line as a line PQ. I will call this as line PQ. What does it say? If a ray stands on it, I have to draw one ray. I can draw a ray here, or I can draw a ray here, or I can draw anywhere I can draw. I will draw one ray here. I will call this as OM. sum of the two adjacent angles is equals to 180 degree. This is called first linear pair axiom. Second, if the sum of the adjacent angles is 180 degree, I will draw sum of the two adjacent angles is 180 degree. Sum of the two adjacent angles is 180 degree. Okay? Sum of the two adjacent angles is 180 degree. See, I will say x, y, z and p. These are the two adjacent angles. See, x, y, p, y, z are the adjacent angles because they have a common arm and a common vertex. So sum of the two adjacent angles is 180 degree. I can say sum of these two adjacent angles is 180 degree. Then the non-common arms, when the sum is 180 degree, then the non-common arms, this is the first non-common arm and this is the second non-common arm. The non-common arms of the adjacent angles forms a straight line. See, this is the first angle, this is the second angle. Sum of the two angles is equals to 180 degree. When they form 180 degree, the non-common arms are always forming a straight line. So these are called as linear pair axiom. For the examination, they ask you for 2 marks: statement, a figure, statement and a figure. My dear children, this is all about the basic terms and definitions which is required for us to solve the problems of lines and angles. After learning all these basic definitions, let us see one problem. First, let us see what is the meaning of this problem. What is the given things? See, first let me tell you, this is one straight line, this is another straight line, and this is a ray. This is a ray standing on the line PQ. What they have given? Angle POM, this angle plus this angle. Both together it is 100 degree. I don't know individually how much is this. I don't know individually how much is this. Together it is 100 degree. Further they given angle QON. This is 60 degree. This angle is 60 degree. They are asking to find QOX. This angle is how much? QOX. Sorry, QOX. They are asking you this is individually how much degree. Find angle MOX. Find angle MOX how much? Find angle PON. Find angle PON. This is how much? And reflex of MOX. One by one we will study. Slowly. Which angles I will show just to focus on that. That's enough. See what they have given. I will write here. Angle POM. Angle POM. Before that. See students? When this is 60 degree, can I say this is also 60 degree? Because these are the two straight lines and we can call them as a vertically opposite angles. When this is 60, this is also 60. Let me write first. Angle QON is equals to angle MOP. This is because I will write vertically opposite angles. So out of these two, which angle you know? You know QON 60. You know this. This is 60. When this is 60, this is also 60. I can say therefore angle MOP is also equals to 60 degree. One angle you came to. When this is 60, this is also 60. They have given this plus this is equals to 100 degree. When you know that when this is 60 degree, can you say this is 60 means this is 40? Because together it is 100 degree. This plus this together it is 100 degree. So with that, can you say this is 40 degree? That we are going to write. I can write like this. Angle POM plus angle QON Because here already it's given that it's 100 degree. Together it's 100 degree. Out of this which angle you know? Just now you have found angle POM is 60. POM, MOP, POM are the same. This is 60. I will substitute here 60 plus angle QOX is equals to 100. Therefore, angle QOX is equals to 100 minus 60. Therefore, angle QOX is equals to 40 degree. You came to know the second angle. This angle becomes 40. Okay. Now what I can write? Now I have to find which angle. I have found QOX. I have to find the MOX. This angle has to be found. See, when you add these three, it will be 180 degree because this is the straight line. This is the straight line. So can I write like this? See, this is sum is 100. That means this angle will be 80 degree. But how to write it in the geometry? The steps are very, very important. I will write like this. See, angle POM plus angle MOQ. Listen properly. POM plus MOQ. MOQ is equals to 180 degree. This is because of linear pair axiom. We have studied in the previous video. We have studied what is linear pair axiom. If the sum of the two angles are 180 degree, then we can call them as linear pair axiom. It is a straight line. These are the two adjacent angles. So when the non-common arms are forming a straight lines, then the sum of the two angles was to 180 degree. This is what you have learned in the linear pair axiom. Now what I will do? In the place of MOQ, I can write MOQ is the sum of this angle and this angle. This together gives you MOQ. I will write here angle POM plus bracket MOQ. I will split into two angles. This plus this. That means MOX, XOQ. I will write angle MOX plus angle XOQ. Angle XOQ is equals to 180 degree. Just what happened? This I have split into two parts. Okay. But what I know? I know sum of these two is equals to 100 degree. I will rewrite it like this. Angle POM plus this I will write it first. This I will write it next. So that because sum of these two is equals to 100. Otherwise also I can write like this. I can just show one arrow mark like this. POM XOQ together is 100 degree. I can say sum of these two is equals to 100 plus angle MOX is equals to 180. I can keep MOX there itself. Therefore, angle MOX is equals to 180 minus 100. That gives you 80 degree. You got this angle as 80 degree. What is left out? Angle PON is left out. It's very simple. Sum of these two is equals to 180. Linear pair axiom. And this is 60. This is 120 degree. I can write that. How I can write? I can write like this. Angle QON plus angle NOP. Angle NOP is equals to 180 because we can say linear pair axiom. Linear pair axiom. Which angle is known to you? this angle 60 degree, you know. Angle QON 60 plus angle NOP is equals to 180 degree. Therefore